Okay. All right. Well, good afternoon, everyone. Thank you for joining us here for the latest edition of South Florida Arboriculture and Landscape Professional webinar series. So today we got a professor from School of Forest, Fisheries, and Geomatic Sciences, Dr. Michael Andreu, and he covers a variety of topics through the College of Agriculture and Life Sciences up there for his classes. But one of the big ones is dendrology and tree ID. And so he's going to get us as far as we can in 1 hour here. But with that, I'll go ahead and pass it off to Dr. Andreu.
All right. Thanks, everybody. And the screen is sharing, right, John?
Yes, it's showing
Okay.
up.
All right. Well, good afternoon, everybody. It's good to be here with you all. Looks like everybody did very well on that pre-quiz. So uh, I'm going to sort of take this approach that while we have perhaps some folks that are not as experienced with Tree ID, maybe some of you are very experienced with Tree ID, and you're taking this as maybe a refresher. But one other way to think about maybe what we're going to talk about today is thinking about how you want to communicate Tree ID to others. So that might be another sort of lens to approach this. So I start off this slide here, and one of the things I say when you begin to do Tree ID is to not get overwhelmed, and because it can be very overwhelming. And so one of the things I say is, hey, first things first, you want to slow down and look around and observe where you are and what's going on around you, and observe the plant itself, and start looking and experiencing things in maybe ways that you previously didn't do. And so look for those things that are curious and be curious. And so in this case, I got this picture of this tree that certainly looks a little bit abnormal. And so you begin to think about what's going on there and why does it look this way. And turns out this is in a swamp. That tree germinated. You can see some cypress knees around there. That gives you some hints that it's a swamp. This tree ended up germinating. The seed germinated on an old log that's later eroded away and left this tree growing and looking like it has, it can walk around and it's up on stilts. So kind of cool way to think about things. But again, slow down, begin to look around and be curious. Again, what I want to do with this talk is and what I try to do in the course that I teach, is try to break down this idea of plant blindness. And I don't know if y'all have heard that term before or are familiar with it. But plant blindness is this idea that society as a whole, we are becoming increasingly removed from nature. And we're not, many people don't have any real awareness of the value and importance of plants that they provide to us and the services that they provide. They see things as just green out there. They don't recognize species and differences between species. At best, maybe they might be talking about things in terms of that's a pine and that's some other kind of tree. And again, they don't begin to appreciate that the values and the services that they're providing. So with Tree ID, we're trying to break that down and begin to get people to see things differently and to sort of become more aware of the trees and the plants around them, and begin to recognize them. Again, when you begin to learn about Tree ID and Plant ID also, it can be really overwhelming if you think about it. I mean, there's so many different species out there, and people sort of approach it with, "I got to know them all if I'm going to be able to identify things," and that would be impossible. I mean, worldwide, there's somewhere between 65, 75,000 different tree species in the world. In North America, there's over 1,000 tree species, and in the USA alone, we've probably got about 880 of them. So and the southeast is really where they're close to half of them are here. So it would be overwhelming to think you've got to know them all. And so we've got to break it down and begin to create a process to think about what is it I'm looking at. Can I create a set of filters that can help me, that I can walk through and work through to begin to narrow down what the potential species is. And so that's what we're going to talk about is that process today. So we start off with some of the first three things I like to think about when I'm identifying a tree, and that is, most people think, well, you're going to talk about leaves. Well, no, the first three things I'm going to talk about are range, habitat, and bark. Okay. And so, range, we're talking about where this tree evolved, where can it grow potentially, what habitat is it found in, whether it's wet, upland site, wetland site, whatever, and some features of the bark. So what do we mean by, and by the way, I don't know how this works, John, but if somebody wants to ask a question or slow me down on something, please let them chime in, and we can create a little bit of a dialogue if they want. Um, so first thing I want to think about is range. And when we think about a tree species, it evolved in a certain area, and so it has what we call a native range. All right. And so in this case, I'm showing on the map on the left, I'm showing you the map, the native range of where loblolly pine grows. Okay, Pinus taeda. And you can see it extends up north of Virginia, all the way down through Florida, west over to Texas. And so that's its native range. And one of the things you can see in this map is that it doesn't extend all the way through Florida here, and so it's evolved and grown with the disturbances in the soils and the climates of these areas. But in South Florida, there it doesn't really show up, and so that's an example of how understanding the range can influence what trees you might expect to see, especially when you're talking about walking around in a forested setting. Okay, so when I'm walking around a forested setting and looking at see a pine tree down in South Florida, I'm not expecting to see loblolly pine as one of the species based on this range map. Okay, now to the one to the right is sort of shows you, well, where could this tree actually grow if it was tended to? And, you took care of it. And that's going to be more like what you'd expect to see in urban settings. Because in natural settings, we don't, they're competing against other species and there's not somebody there ensuring that it can survive. Whereas a tree can maybe survive in a broader range of conditions in an urban setting if there's somebody there tending to it, taking care of it. And so you can see this map on the right shows where loblolly pine might be potentially found in the United States, growing, and you can see it extends all the way up to Washington State and much further north on the East Coast and much further south in Florida. And so those are the climatic conditions that would allow it to grow, but would not be evolutionarily where it would be found normally. In addition to those places in the United States, loblolly pine actually is commercially grown in a lot of other parts of the world. South America, Asia, Australia, Africa, and these are in places where pines don't even know pines exist south of the equator. And so, we have taken these species much beyond their natural range. But just make sure you understand what you're talking about when you're talking about the range. You're saying whether it's its natural range or where it can actually grow. Habitat's another one. Again, it is very relevant, especially if you're talking about forested settings in Florida, because it dictates what plants you might expect to see. In Florida, especially South Florida, we don't have a lot of elevation changes. That said, elevation changes in just a few feet or even measured in inches can make a dramatic difference on what species you would expect to find there. And so, understanding that and beginning to slow down and recognize those nuances in elevation changes can help you begin to think about what potential species you might expect to occur there. Now, again, in urban settings, as many of y'all are working, that rule doesn't work as well. However, understanding where a tree would naturally grow helps you better think about what tree is appropriate if I'm going to plant it in a given site. So still understanding habitat's important. It may not just be as helpful in an urban setting in helping you identify a tree as it would be perhaps in a forested setting. Let me just give you a quick example of how habitat can be helpful. So Quercus laevis or turkey oak is a species that's sort of associated with dry, upland, well-drained sites, and often associated with Pinus palustris. And so, if you know that, if you have that simple understanding, that can help you think about where would I expect to see it if I'm walking around. And so this next picture shows sort of a setting where clearly we're walking around, looks like a spring maybe, and here in Florida, it looks like maybe these areas that spring might at times flood beyond its current levels. And so, based on those conditions, well-drained, dry soils, this does not really look like a great place where I'd expect to see turkey oak or Quercus laevis growing. So when I'm looking around, that's off my list. Okay, that is not one of the potential species I expect to see. And so that's again what we're trying to do is find filters that help us make decisions on what species it is and what species it isn't. And this is an example where habitat can be helpful. Okay, here's the second picture is of this site. This is an upland site. This is a sandy soil. This has Pinus palustris growing, and this is exactly where I'd expect to see it. So now I'd be looking for it. In this picture, I actually don't see any in this picture, but this would be what I would expect to see a site for Quercus laevis or turkey oak. So just a quick example of how you can use habitat to understand what species you might expect to see and what ones you don't have to worry about. So where do plants grow? A lot of times people talk about, well, plants grow in places that they like, and really that's not always the case. So in this graphic here, what you'll see on the x-axis is sort of down here on the bottom axis is goes from dry to wet, dry, xeric, mesic, hydric. All right, and you can see, and then on this y-axis, the upright axis, it's just relative competitiveness. Okay, there's no real measure there. But what you can see are three different species displayed here. And one of them is longleaf pine. We just talked about that, and that's a species that tends to like those well-drained sites. We think of them as more on these well-drained, steep, sandy soils. All right. White oak is one that tends to be, we think of it growing more on these drier sites, not in real wet conditions. And then sweet gum, boy, that's one that can grow in wet and dry conditions. And so this sort of helps you illustrate those range of conditions where you might expect to see those trees. So longleaf is that dashed line, white oak is the dotted line, sweet gum is the solid line. And so what you can see is their relative competitiveness. And so on the far left there in xeric conditions, longleaf is the only one that extends over there into the drier sites. Okay. So that's why we tend to think of longleaf as being associated with drier conditions because nothing else, of these three at least, really grows out in those sites. So if you were to grow all three of these together, well, longleaf's going to have the competitive advantage and be the dominant species there. Meanwhile, if we go over to the hydric end of this equation or this graphic here, we can see the same sort of thing out there in those wetter sites. As it gets wetter and wetter, sweet gum is sort of the dominant species. But if we look right there in the middle, mesic, all three show up. However, if you look at the curve height, the relative competitiveness of the three is not the same. So in this case, in the mesic site conditions, longleaf is much lower than sweet gum and white oak. And so when you're on those really nice, rich, moist sites, longleaf could grow there if it was tended to. You could have it survive and grow, and it actually would grow better there than it would out there on a dry site. But when it's growing in competition with other species that can also grow there, which there's a lot are going to be able to grow on that mesic site, in this case, white oak and sweet gum, it gets outcompeted. So when we look at those drier or mesic sites, we don't think of them as a place where longleaf could grow. We think of them as more, that's why we see mixed stands of white oak and sweet gum. And so it's a helpful thing to think about. In urban settings, if we want to plant that longleaf there, we could. We're just going to have to really tend to it and ensure that it's not competing with other things. Okay, so just to take this one step further, think about cypress and what its curve would look like, and sort of visualize it in your head, and then I'll show you what I tried to draw in. It's not perfect, but I tried to draw it in. So cypress, it actually would occur sort of over here. Again, we think of cypress as growing out there on those real wet sites, and that's where it occurs. But the reality is that it extends back into those mesic sites. It's just not as competitive. But how many of y'all have seen and tried planting and maybe worked on trees that are growing on drier sites, that cypress trees that are growing on those drier sites? They're doing fine, and they're not as competitive as other things. So again, the mantra that I sort of have that is that uh, trees grow where they compete best, but they can often grow on a wider range of site conditions than we tend to think of them. Okay, and here's an example of how trees can grow in different places outside their natural range, native range, and in conditions where they've been tended to and worked on. Does anybody recognize the tree that's got the flowering species, the tree with the flowers on it? Anybody? Oh, I've got it down there in the corner. So it's Lagerstromia indica, grape myrtle. And so, there it is. It's from Asia, shouldn't be here. So range really doesn't help us make an ID on this at all. Habitat, God knows this is a backyard and the soils are different. The hydrology is different. This is a completely contrived situation. So those kinds of things don't help us here for ID. We can see some flowers, but that may be helpful. But what actually is here, and I think interesting, is this tree, this particular species, actually has a nice feature, which is bark, which is our last thing to talk about. So again, when we think about tree ID, a lot of people think, well, we're talking about leaves, but for me, I sort of try to filter it down and begin to think, try to ID things as using these other clues first to reduce the options I might be considering. And bark is one of those things that's very helpful to begin to use early on. I try as much as possible to encourage students and people new to tree ID to try to start looking at bark and get that in your head and start looking at things like the different textures and the roughnesses of the bark, the thicknesses of the bark, the colors, and other features. In this case, certainly this tree is armed with all these thorns on that. And so this one's an easy one. You don't need leaves to ID this tree if you see it growing out there. It's very distinct. It's Aurelia spinosus, and the common name on that is devil's walking stick. So I'm just going to walk you through a few other examples. This is another one that, to me, bark, I don't need any leaves to make an ID on this. I can identify it from the bark alone. I know where I am located here in Florida. Geographically, that's important to help me, begin to ID this thing. In this case, I'm walking around in a more of a bottomland situation, and I come upon a tree that's got grayish bark with what appears to be sort of warts growing all over it. That's all I need. I don't need to look up. I can use those clues and determine this is Celtis laevigata or sugarberry. Another one, very distinct bark. You begin to look at these patterns. And if I don't know if you can see the mature tree on the left, but it has sort of a braided pattern, a anastomosing bark, we call that, and sort of that diamond or braided pattern on it. That can be a very distinct feature, and you can look at it, and it'll change. The bark's not always, doesn't stay exactly the same throughout the tree's life. On the right, you can see that same tree and younger, but it is beginning to show, even as a young tree, some of that pattern, that diamond shaped pattern. But you see something like that, and then you couple it with another piece of information, like these nuts down on the ground. You look down, you can make an easy ID, and you can see this one is Caria glabra, or also known as pignut hickory. And that's a combination of knowing where you are located, site. This is another bottomland hardwood area. and the bark pattern, and then those nuts and that open nose, open looks like a pig nose. That hickory nut ID done. Don't need a leaf. This is another one growing in bottomland hardwoods that I find very easy to identify. It's got smooth gray bark, kind of like that Celtis, but instead, the stem of this tree and the bark is fluted or looks like sinewy, like Superman's arms or cartoon figures' arms. And so this one is really easy to identify as Carpinus caroliniana. But look at this one. It's got a whole bunch of different names: ironwood, musclewood, blue beech, and hornbeam. And every one of those names is commonly used just depending on where you are. And so that goes to sort of begin to think about, what are we doing with the naming process? Why do we want to try to use, if at all possible, that genus and species or the Latin binomial as much as possible, not because we want to show off or be snooty, but because we want to make sure we're being exact and talking about that species. Because with a name comes not just a name alone, also comes a whole lot of information. We've already sort of talked about how you know where that site, what kind of site it grows on. When you know the name. You know something about where you are located in the world when you know the name. And so the name brings with it more than just a name, it brings information associated with it. And so in this case, you could be talking about ironwood and somebody else could be talking about blue beech. You're talking about the same tree, but have no idea. So ideally, when possible, try to use the Latin binomial. Here's some others, bark, and I'm just going to run through these real quick. Again, this is one that when I see this bark, deep fissures, thick bark, wide flat ridges. It's Gordonia lasianthus, loblolly bay, growing down in a wetter area. I don't need a leaf. I can make my decision right away. Likewise here, got some hints, got some water nearby, spring. This one's growing in near spring, flaky bark like this, Betula nigra, river birch. Easy ID. I don't really need leaves to make my identification on something like that. So that's examples of where bark can be really, really helpful. This is one site that not necessarily doesn't look like a wet site. In fact, it is a wet site. You can see where the floodwaters get to at times. These lines right here sort of show where the water gets up to. But it's formed these buttressing bases and that shaggy bark, reddish brown shaggy bark, and that's an easy one to identify here in combination with the clues of site and the bark. I don't need to look at the leaves. I can tell you at least it's some kind of cypress. Now, it would be helpful because there are multiple cypresses that sort of share this form. We have two here in Florida, pond cypress and bald cypress. And so we would, really the best way to ID this would be to help have some additional information, like go down, look on the ground, and look at the leaves themselves. Uh, Bald cypress, the leaves stick out from the branchlets and they look like a feather. And Pond cypress, the leaves are upright along the branchlet and they are ascending upwards, or Taxodium ascendens versus Taxodium distichum. So that would be helpful. There's other sort of little cool rules of thumb that you could use to make your identification here just by sight alone. We tend to think of bald cypress associated with moving water, whereas pond cypress is associated with isolated ponds more likely. And that's not an absolute perfect rule, but it works a lot of the time. In this case, this was an isolated pond. And so we would have a good bet at saying this is most likely pond cypress or Taxodium ascendens. More bark. This is black cherry or Prunus serotina. Very distinct bark. It has these lenticels, which are for air exchange or gas exchange. And that's a very distinct feature that shows up on this bark throughout its life. So in combination with that sort of cracked, thinnish bark, silvery, gets black at maturity, and then those lenticels that stay on the bark throughout its life, very easy to identify without looking at leaves. This is another one from bark here, Quercus alba, white oak. And this is one where you would not expect to see it in Central Florida. You wouldn't expect to see it in South Florida because its native range really ends up in around Tallahassee area. And it does not naturally grow outside of that area. This one happens to be growing outside that area, but the bark can get you very close to the species. Doesn't get you fully there because other white oak type oaks trees share that same bark, but it would get you at least a white oak. And in this case, once you looked at the leaves, you could make a determination that it's Quercus alba. Probably most of you recognize this bark. We've all climbed in these trees as kids, probably. This is has a very distinct bark. You can see it from afar, live oak. Now, that's Quercus virginiana, and this particular one, certainly that bark is shared also by Quercus geminata, so that would require you to look at some other features like know something about the site and or look at some specifics of the leaves to make your determination. Lastly, here, this tree on the large tree on the left, the bark is very distinct. It's a tight bark. This is an oak tree of some sort. It's a bottomland area. But what I really want, so this is Quercus laurifolia, and that bark's shared by three different species: Quercus laurifolia, Quercus hemispherica, and Quercus nigra. So bark alone doesn't help you on that tree, but it gets you close. Now, what I really want you to see here is sort of imagine in your head, you're down in this bottomland area and you're looking at a gray bark tree, sort of smooth bark, and you see a bunch of warts on it. What would that species be? We've talked about it already. Anybody, can you come up with that species? I'm going to say we talked about it, warty tree, gray bark, smooth gray bark. That's a sugarberry or Celtis labigata. All right, so you can start to think about and see how you can make ID without even looking at things. Lastly, barks, again, can be helpful. It can get you down to maybe a genus. In a case of pines, I find that pine trees that we have here in Florida, at least the major yellow pines, southern yellow pines, the barks are very similar. So you're going to have to look at definitely other features like the twigs, the needles, and the cones to make your identification. So let's talk more about other tree species and let's pick up, we've talked about range, habitat, and bark. Let's look at the leaves. And there is a whole bunch of things you can look at when you're looking at leaf, and they are incredibly helpful for identification. But the first thing you got to do is you got to determine what is a leaf. Leaves come in two forms. They come in simple or compound, and so you got to make that determination. Then you begin that, and that's very helpful to do because there's a whole lot of species that have simple leaves. Far fewer have compound. So as you're approaching a tree and beginning to think about identifying it, try to first make that decision. Am I looking at a simple or compound leaf? Because that will help reduce the number of potential species. Likewise, with leaf arrangement, we'll talk about this more in a second, does the same sort of things. Leaves are arranged along the twigs. Once you've identified what is a leaf, you look at how they're arranged along that twig, whether alternate, opposite, or whorled. And a lot of trees have alternate arrangement, far fewer have opposite, and even fewer have whorled. So if you can begin to think about that, wow, that can help them tremendously reduce the potential species you're looking at. So how do you determine whether something's a leaf or not? Well, on the left, you can see what we call a simple leaf. Okay, and that's sort of the generic leaf we all drew as a kid. And so what you're going to do is follow that midrib all the way down through the petiole there and see where it's attached to the twig. What you'll see there is an axillary bud. Okay, and that bud is where it attaches to the twig. That's your indicator that everything beyond that is at one leaf. So in this case, we're looking on the left-hand side, we're looking at one leaf, a simple leaf. If we look over here to the right, you can see these things that appear to be leaves, okay? And there's, see those 5 things that appear to be leaves, but if you trace them down to where they attach to what appears to be a twig, there is no axillary bud. And so you need to continually follow that. That's referred to as the rachis running down there to the petiole where it attaches to the twig. You'll see that axillary bud. And now that lets you know that that entire thing is one leaf. It's a compound leaf. And each one of those things that might at first appearance look like a leaf are actually referred to as leaflets. Again, many species have simple leaves. Far fewer have compound leaves. So beginning to recognize whether I'm looking at a simple or a compound leaf It's going to be your sort of first filter as you're walking up to the tree and making your ID. Okay, so now, and this is the thing about in tree ID, there's all kinds of vocabulary and things you got to get used to and words you need to hear and get comfortable with. And that just comes with practice. But there's lots of different ways to then describe or define the type of compound leaf you have. And so the most common ones are sort of these pinnately compound leaves. So that entire thing is one leaf and the leaflets are emerging on either side of the rachis. We've got two of them that are pinnately compound here. This is evenly pinnately compound, even number of leaflets, oddly pinnately compound, odd number of leaflets. We got bipinnately compound, okay, twice divided. So it gets, you can begin to think about these things. You guys might be familiar with, say, poison ivy has a trifoliate leaflet or three leaflets on it commonly. Parthenocissus, you got Virginia creeper might be a species you're familiar with. It's got five leaflets. All right, so different numbers of leaflets, and when they have five like that, and they're all emerging from one location, that's referred to as palmately compound. So different kinds of compound leaves, and so that can be very, very helpful in making your identification quickly. Now, one thing to be aware of: leaves. Sometimes I teach some engineering students, and they expect all these leaves to be stamped out perfectly. Bam, bam, bam. You showed me a picture of the species and it looks like this. And now when we go out and looking at it, it doesn't look exactly like you showed me. And they get frustrated. You can't get frustrated. These are biological things and there's variability associated with them. And so that variability can be genetic variability. It can be associated with where on the tree that leaf is showing up, whether it's up high or down low. And so this example here shows you six different leaves. These were simple leaves, all from the same tree. If you were to show a typical and say, well, typically the leaf that this tree has, water oak, is this one on the lower right-hand side. It's a spatulate shaped leaf. This is a water oak leaf. But then you go and you see them looking like this. And this all came from the same tree. That could be frustrating to people as you're beginning. So be aware, some trees, some species have a higher propensity to have a lot of variability in their leaf form and shape. Others are more consistent. However, size can vary based on the age of the tree, based on the location of the tree. Certainly in urban settings, you've got a lot of stressors that the tree might be dealing with. And the location, even within the canopy of the tree, can influence the shape of the tree. So just be aware, variability is normal. Now here's leaf arrangement. We talked about that as an important variable. And in this case, these are all simple leaves. How do we know that? Well, we look for that axillary bud. There it is right there. So I know that everything beyond that's a simple leaf. And now we look at how those individual leaves are arranged along the twig. So here's a leaf. Can you guys see my arrow? John, can they see my arrow?
Yes, we
Yes.
can.
Okay. So here's a leaf here, leaf here. They are alternating along the twig. Very technical term we have to describe that arrangement of the leaves is alternate arrangement. Okay. When trees come out, when the leaves, these are also, let's see, these are simple leaves. Again, we've got axillary buds there and there. Okay, so these are simple leaves, and these leaves are emerging directly opposite of each other. Okay, so that's what we've referred to as opposite arrangement. And here we got another set of simple leaves. Each leaf has its own axillary bud, and they are all emerging three or more from one location along the twig. That's referred to as whorled. So those are three leaf arrangements. Many species have alternate arrangement, fewer have opposite arrangement, even fewer have whorled. And in some cases, you might find some species, buttonbush, Cephalanthus occidentalis, it has both opposite and whorled. So that really can help narrow it down if you see it. So you can see how these could be helpful features, first knowing whether it's a simple or compound leaf, then knowing how it's arranged along the twig. Here's some examples of real world pictures. First thing here on the upper picture here, we want to determine whether these leaves are simple or compound. We're going to look for that axillary bud. There it shows up. So we can determine that these leaves are simple. Okay. And then how are they arranged along the twig? There's a leaf there's a leaf, there's a leaf there. So they are alternating along that twig. So they are alternate arrangement. All right. This is Liquidambar styraciflua or sweet gum. And there's its fruit. Boy, you step on one of those, and you don't need any leaves or to look at all that. You can just make your decision right there. Likewise, we look at the lower right picture. And again, these leaves, often people mistake these two species. I don't know how many times my students make this mistake in the beginning, not by the end. And they see these leaves, they have similar appearance. They're lobed leaves, sort of look similar, but then they need to look at this arrangement. In this case, the arrangement is opposite, so simple leaves, but they're coming out opposite from each other. Now they can make that decision. This is red maple, Acer rubrum, and I can tell that because it's got opposite arrangement. And so again, this can be a very helpful thing to determine. And the fruit's very different, of course. So just asking yourselves again in your head, sort of answer these questions. I'm showing you a picture on the left. Is that a simple or compound leaf? How would you make your decision? And you say, well, Dr. Andrew, I'm supposed to look for that axillary bud. So I'm looking here. This thing looks like a leaf. I'm looking, I don't see an axillary bud. I follow it all that, I don't have a twig here, so I don't know. Well, let me give you an axillary. There's your twig, and there's your axillary bud. Now you can readily make a decision. This is a compound leaf. And going back and think about, well, what kind of compound leaf? This is a pinnately compound leaf. And we could even further say it's an oddly pinnately compound leaf because we got that terminal leaflet. Likewise, over here, we've got a compound leaf, and it's twice divided. So this is bipinnately compound. More pictures. There's your trifoliate compound. You got your terminal, your axillary bud right down there. And this is that Parthenocissus quinquefolia, Virginia creeper, compound leaf, palmately compound. And you've got your axillary bud there to help you make that decision. Okay, again, I'm going to tell you now, these are compound leaves. I don't have my little twigs here drawn in, but people make this mistake all the time when they first look at it. They say, hey, these are the same species or very similar. What else can I look at to make my decision? Well, these are the one on the left is a hickory, the one on the right is an ash. And as I said, it's more common for things to be alternately arranged, far fewer species are opposite. Ashes happen to be one of those species that have compound leaves and are opposite. Man, that really reduces its potential. When we look at these species up close, we can see, in fact, they are, here's that axillary bud, and we can see that's the compound leaf there, and we can see they're arranged alternating along that twig. So this is pinnately compound and alternate. Likewise, this one is coming out opposite on either side of that twig. You can see that axillary bud. And so this one is pinnately compound and opposite. All right. So this is beginning to help you sort through these things and look for features. Man, we can also look at lots of other features of the leaf, the shape of the leaf. There's lots of terminology associated with that. So you just got to get comfortable with it. And it's like learning another language. Make it fun, but get used to using that terminology to describe things because we want to be able to communicate to each other as professionals, to our clients, and use that kind of terminology appropriately. So this sort of gives different definitions of shapes of leaves and what makes something elliptical, which is that generic shape leaf that we all, versus oblanceolate. So you can sort of read those different definitions and you'll need to get used to using that terminology. Lastly, another shape of leaf, real common, is lobe leaves, and we'll see there's lots of different ways to describe different kinds of lobing and the depths of the lobe, whether it's rounded or more sharp, things like that. Other features that we begin to look at is the venation. And just like we can describe compound leaves differently, the way the veins emerge from the midrib of the leaf can be helpful for identification. You can see here on this leaf, the veins are emerging from either side of that midrib. All right, and so that's pinnate venation, just like the leaflets were emerging from either side of the rachis. All right, and that made it pinnately compound. This is pinnately veined. All right, so some terminology transfers from one characteristic to another. Okay, this is palmate leaf ant. We talked about palmately compound leaves where all the leaflets emerge from a single location. This is palmately veined. All right. And so you can see all the major veins come from one location. All right. And this is by the way, this is a sweet gum or liquid ambar styracid fluid. And this is subpalmately vein, meaning you've got two major veins coming down from one location, but then the veins are coming off the midrib. And so that's what we refer to as subpalmately veined. Again, just different ways to describe the leaf and various features on the leaf. One very common way to describe the leaf, are by describing the outside edge of the leaf, or what we refer to as the margin of the leaf. That's that outside edge. Again, there are many, many, many different terms to describe that outside edge, whether it's smooth, which we refer to as entire, or if it has some kind of teeth on it or something. Real common ones like here you can see are serrate. Those are ones that look like the edge of the leaf looks like a saw. And then there's doubly serrate. That's where each actual serration has serrations on it. So serrations on serrations is doubly serrate. Entire is smooth. And then there's, again, many other ways to describe them. You just got to get used to using that kind of terminology. So there's an example of entire, okay, a smooth outside edge of that leaf. This is what we refer to as revolute, is that leaf edge is curled up and it's sort of curled in. That's a revolute margin. This is crenate, okay, you can see it looks like somebody took craft scissors to go around the outside edge. That's crenate. There's dentate, okay, and that looks like the teeth you'd carve in a pumpkin, right? They look like teeth. Big, large serrations. Okay, there's serrate, looked like a saw tooth, and then there's an example of that doubly serrate. When you see these kinds of things, that can help you make decisions as to what species it is you're looking at as well. So this is, again, slowing down, beginning to look at things and details that maybe previously you didn't do in the past. Other terminology and things you need to be aware of when looking at leaves is you can describe the top half of the tree. We call that the apex, or not the tree, the leaf, excuse me. And we call that the apex of the leaf. More terminology that you might encounter. These are some common terms: acuminate, acute, obtuse, mucronate, rounded. And here's some examples. What are we talking about when we're talking about the apex of the leaf? Usually we're sort of talking about that upper third part of the leaf, where that line is, and we're sort of describing that shape there. In this case, it's acuminate, which is elongated, sort of a slow elongation. So that's an acuminate apex. And then this one here is sort of like, think about back to geometry. It's an acute angle, less than 90 degrees. So it's not a sharp point, but it's an acute angle, so that's an acute apex. This one is more obtuse. It's not a perfect example here, but it's greater than 90 degrees, so it's an obtuse apex. And then here on this one on the right, you can see out at the tip of the leaf, and actually at the tips of all the lobes, you can see a little hair or bristle, and that's referred to as a mucronate apex. Rounded, another technical term to describe that leaf apex there. And then this one's emarginate. This is one where the leaf apex actually sort of indents into itself and comes together. So that's an emarginate apex. So lots of ways to describe the leaf. And we can do the same thing with leaf bases. Many, many ways to describe them. Acute, a repeat, obtuse. Those were two terms. Cuneate is sort of like the opposite of acuminate. So it's a long point that comes to here, elongated. This one's kind of interesting to talk about. We talk about this being inequilateral, meaning if you were to fold this leaf in half, this side, the base of the leaf, is smaller than this side. That's kind of clear. But this one also has a secondary feature, and which means it's oblique. If you look at this leaf down at the bottom, you'll see where the blade comes together, it doesn't come together equally with the right-hand side. The left-hand side doesn't come together equally with the right. And so that's what we refer to as an oblique base. So this leaf the base is both inequilateral, meaning it's smaller than the one side than the other, and it's oblique, meaning the sides don't match up. Again, more examples, cordate leaves and truncate, meaning sort of flattened across the bottom. So those are some of the features of the leaves. Other terms you ought to be familiar with when we look at leaves. We can look at the surfaces of the leaves, and there's terminology associated with that. Some leaves, the surfaces might be incredibly helpful for identification purposes. Okay, think about magnolias. Some of them have that red hairs on the underside of the leaves. We refer to that broadly as pubescence, but botanists have many, many, many terms to describe the hairs of a leaf. And so, I mean, they need jobs too. And so that's job security there. So, but I broadly just sort of lump them together as, pubescence on the leaves. And sometimes one surface of the leaf will be pubescent and not the other. Sometimes both surfaces, sometimes the petiole of the leaf will be as well. So those can be helpful characteristics to look for identification purposes. Two other terms that sort of get tossed around that sound similar but are different. Glabrous, that means a leaf surface that is without hairs. Okay, so it's like the opposite of pubescent. But then also something that sounds similar is glaucous. And glaucous refers sort of to a silvery, blue-gray, waxy surface that might be on the underside of the leaf, might be on both surfaces of the leaf, and can rub off. You can sort of rub it off. And so don't confuse glabrous, which means without hairs, with glaucous, which refers to that waxy surface that's on the leaves. There's an example of some form of pubescence. That's a heavy pubescence on the underside of that leaf. And we look at this leaf, the upper surface of this leaf, and this is Magnolia virginiana, by the way. So this is glabrous, no hairs on top, and then it has a glaucous underside, which is a key for identifying this tree from afar. If you see that glaucous underside, really easy to ID it. And if you rub that off, it would come right off. Okay. Lastly, about leaves here is persistence. Again, this can be very helpful if you know once you have, know about your trees and thinking about what it is I'm looking at. Knowing whether they happen to be an evergreen or a deciduous species can help you make your decision depending on the time of year, right? And so in this case, we've got two species that many, many people mix up at first glance. They look similar. They have simple leaves with alternate arrangement. Both of them are sort of glabrous on the surfaces, sort of very, very similar shape. The margins, this one has serrated margin. This one has, well, maybe some kind of serrations on the margin. So, geez, I don't know. But if I'm in midwinter and I'm looking at this tree, Prunus serratina, is deciduous, whereas this tree is evergreen. So when I walk up to this and I see something and I'm like, is it a Prunus serratina or Prunus caroliniana? But it's midwinter and I see leaves on there. I'm like, I don't have to look any further. There are other features that might be helpful for making our decision, but just knowing that alone can help me make my decision. So again, what you're trying to do is collect a series of filters that can help you make your decisions quickly. Lastly, don't forget, this is a full body, full sensory experience when you're getting into tree ID. Don't forget about smell. Certain leaves have distinct smells versus others. In this case, Prunus caroliniana has a very distinct, when you crush it up and rub that, heat up the oils in it, smells like maraschino cherry. And so that can be a helpful thing. Taste even sometimes can be helpful. So how are we doing on time? We're starting to run out of time. So that's it about leaves. There's other things you want to look at when you're doing ID. Certainly looking at the twigs and various features on the twigs can be helpful, especially if you've got a deciduous species and you don't have any leaves and you're uncertain what it is. Looking for the leaf scars, looking at stipular scars. Here's the sort of the anatomy of a twig. There's again, even with leaves off, you can make decisions as to whether something is got a alternate or opposite arrangement. This twig on the left There's a leaf scar where a leaf used to be. There's a leaf scar where a leaf used to be. I can see that pattern goes down that twig. This one has alternate arrangement. I can see on this second twig here, the leaf scars are opposite of each other, and I can assume there's one opposite of that one. So I can assume this one is opposite arrangement. What I cannot tell is whether these are simple or compound leaves just by looking at the twig alone. Okay. So there's some things you can determine, but not other things are not able to do. Other things like magnolia species, family, all those species have what we call stipular scars. And in this case, the stipular scar is a leafy appendage that comes out when that leaf emerges. And in this case, it's deciduous. It drops off very quickly, but it leaves a scar where it once was. And so the magnolias sometimes can be tough to distinguish from other bay-like trees, but looking for that presence of that stipular scar that completely encircles a twig can be a very helpful feature for identification of a magnolia. There's tons of things to think about with flowers. We're not going to go into them. Certainly, some flowers are what botanists use for making decisions for tree ID. But for me, as a practitioner, I can't wait around for flowers to show up. So I've got to make my ID ahead of time, without them, with or without them. And when you got them, they're great and they can be very helpful. Not all flowers are showy. So these are some examples of some showy species flowers. And here's some examples of flowers that are not. A lot of people don't even realize oaks actually flower, but we just don't think of these as flowers. So kind of good to think about. Also, some trees have male and female on separate plants. Some people will have them on the same plant. So that can be something to keep in mind as you're learning to identify. And again, just because they're pretty, sometimes they can be problematic, as is the case in these two species. And then finally, fruit. There's dry fruits and there are fleshy fruits, more ways to describe them. Those can be incredibly helpful for identification. We talked about how hickory nut could help confirm you're looking at a hickory of some sorts. And so that can be very helpful once you're doing ID, but they're not always there. And certainly they might be cleaned up in an urban setting, might have been raked up or swept up, so they're not always there and they're not always there throughout the year. So I rely less on fruit and use those other features first. Okay. And here's some examples of some fleshy fruits. All right. And what you might expect to see. Lastly, our reproductive features of pines. They're not flowering plants. They don't produce a fruit. They reproduce with strobili and cones. So they'll have male and female strobili that then produce these woody cones, and these cones can be helpful for identification purposes as well. They come in all kinds of forms and shapes and sizes, and different gymnosperms have different kinds of cones, and that can be helpful. So not all cones are cone shaped. All right, that's what I've got. That was really quick. And I started off saying you got to slow down. So you got any questions or thoughts?
Yeah, so let's go ahead. If you've got questions, go ahead and please share them. I'm going to go ahead and launch the quiz at the same time, just in the interest of time here. So you'll go ahead and fill those out, but also let's do Q&A at the same time.
They knew it all already in the beginning, so there might not be.
There might be a little improvement. So okay, I went ahead and launched the quiz. And let's see here.
So again, I think it's from you guys' perspectives, since many of you seem to had a lot of experience with Tree ID, think about this as a way to communicate identification to your clients or the folks you're working with. Do you think this was a helpful sort of set of filters to work through and an approach?
At least when I do tree ID kind of on the local level, like that's where I try and steer it. is definitely like thinking about like figuring out where buds are, talking about what buds are to begin with, and um, I think that's a really helpful concept for people that like are kind of at the beginning of doing ID.
Yeah, just even thinking about what is a leaf.
Yeah, yeah. Leaf versus leaflet, like
Yeah.
so. What I got a question, I guess, for the audience, if you all want to respond. Maybe it could be helpful to Dr. Andrew and I. What do you notice, or what do you notice others have the most problem making identifications with? And in particular, I'm curious if like there's anything in South Florida that kind of, something that like might be tropical that or semi, somewhat tropical that you might not see in other parts of the state. Are there any things that consistently show up that people have a hard time, telling the difference between something?
I think that's an interesting question.
Okay. We got Darlene Harris says here in the chat. I know this is going back to what you were asking, Michael. The Yes, this was helpful. Range and habitat and bark are not the traditional approach, which seems just to be to grab a leaf. And many clients give us a leaflet or uh, something without any context to ID it.
Yeah. Yeah, that's and especially when they hand you something that they think is a leaf and it turns out it's a leaflet, it can really sort of lead you down a bunny trail that goes nowhere. So having that context, I think, is important. Getting at least a picture as well as the entirety of the tree can be helpful. But
Oh,
sometimes, uh,
I see here. Young gumbo limbos with smooth gray bark are sometimes hard um, for some to ID via leaf. Yeah, definitely. Like that's one that the color can vary quite a bit in terms of the bark. And so, yeah, definitely like one that I think I've been confused by younger gumbo limbos before too. Okay, I'm going to go ahead and end the poll and share the results here. And of Dr. Andrew, if he can see it, like lead us through the quiz results.
uh,
Is it showing up on your
yeah,
side?
yeah. What do you want me to do? Read the
Uh,
question?
yeah, I guess just go. I mean, some of them they got like 100%, but like if you could just,
100%. Yeah.
yeah.
Number one, they all got it.
So,
100%. So fantastic. Number two, looks like the leaves are commonly arranged in twigs in three ways. So opposite, alternate, and world were our three options. Um, so that's arrangement and compound and simple where a couple people answered that. That's the composition of the leaf, right? Whether it's compound or simple. If describing a leaf, did we get that one? No. The margin of the leaf is serrated. I'm referring to, in this case, what the margin is the outer edge of the leaf, and so that's the A is the correct answer. Um, let's see here. The one aspect of tree ID that's reliably easy is the fact that all leaves of a given species are identical all the time. We showed you our example of the water oak as a really highly variable leaf shape, but even some that are more consistent in their leaf shape, their size, and there can be some differences based on whether that leaf is up at the top of the crown or down in the lower part of the canopy in the shade. There can be variability there. So embrace the variability. Don't get frustrated by it because these are biological things. And lastly, looks like we had 100% correct. So, yeah.
all right, I'll go ahead and stop sharing the quiz then, and then, um, yeah, if you've got any further questions, go ahead, like give me Dr. Andrew like an email, feel free to contact me. And yeah, I mean, okay, there's one more that showed up here in the chat. Um, Quercus tends to readily hybridize, and there's so many times in our field idea will either take the most dominant characteristics or too close to call. So with certain Quercus species. So do you got any insights on that? I know there's a little bit more in terms of Quercus species, like up in North Florida and stuff like that, but with hybridization and I guess the maybe in particular like leaf traits, like
So a couple of thoughts on that are you're right. It can sometimes it's not an easy call and you just make a call. And so that's true. Or maybe you punt back to Quercus species and that's where you stop. But I think you can get a little bit further than just Quercus species. At least you could recognize whether it's a white oak or a red oak and why can that help you better understand some of the properties of the tree. That can help you. If it's a red oak, it's going to be probably a lot more susceptible to rot than the white oaks. And so that can, even if you're still at Quercus species, but you don't know, at least get yourself to which kind of oak it is. And so, really, again, why do you care about the species is so that you can make a decision, a management decision. And sometimes knowing whether it was Quercus hemispherica, laurel oak, or Quercus laurifolia, laurel oak, they look similar. You're not going to, and so, yes, they are two different species, but you're not going to make a different management decision regardless of which one it is. It would certainly be important to understand that species if you're making a decision about planting, but if you're making a decision about trimming or about managing that tree once it's established, it's probably not going to be a big deal. That's sort of what I offer. You're probably going to make the same decision regardless. So that's sort of the way I think about it.
cool. Let's see. Yeah, she just followed up here and said, yeah. And then there's a topic of shade leaves versus sun leaves. I like the presentation, the range of habitat and bark to re kind of rehash some of these things that we think about, I think is what she's saying here. So, but I guess with that, we're at over an hour. Folks are saying thank you. I see a former student, Michelle Danielson. So, so yeah, but yeah, thank you for your time and being part of the series and providing like a kind of a back to basics here for a lot of the folks that work with trees and um and a primer for those that are trying to get into it more.
Yeah, well, thank you for including me. And it's great to see everybody. Hope there was some value there. And holler if you got any questions or things you want to talk about. Happy to do it.
Awesome. All right, folks. If you got questions about CUs or anything like that, like I'll keep you posted as well. I'll send out a follow-up email with a recording. And I mean, but yeah, everything was handled through Eventbrite, and they've been taking yeah, I guess just a housekeeping thing here. Um, ISA changed the system that they use they're trying to make it more automated for CEUs. So that is taking a little bit longer from what we've been seeing, but they've been telling us 4 to 6 weeks. So just hang tight if it seems like it's taking a little bit longer than what it has in the past to get your CEUs to show up online. So, but thank you again, Dr. Andrew, and take care, everyone.
Thank you.